Okay, chapter 29 is ratio solutions. So they're pretty much, we're doing ratio and proportions again. So this chapter should be fairly easy for you. They're just setting it up a little bit different. So you have, after reading through this chapter doing the practice problems, you should be able to convert ratios to fractions, convert percentages to ratios, convert ratios to percentages, and reduce ratios to the lowest terms. And then you should be able to use ratio proportions to calculate the amount of an ingredient needed to prepare a concentration of a specific ratio solution. So a lot of times, the strengths or the concentrations, you'll see them as such as like 1 to 1,000. Okay. And so if it's a water and volume, then that would be, a weight and volume, sorry, weight and volume. The weight would be the 1, so it'd be the gram, 1 gram over 1,000 for the volume, be milliliters. Okay. If it tells you volume to volume, then it'd be 1 milliliter over 1,000 milliliters. Okay. So it could be shown as 4 to 1,000. Again, if it was weight to volume, it'd be gram over milliliters. If it was volume to volume, it would be 4 milliliters over 1,000 milliliters. Okay, so number 1, you are to prepare 2 milliliters of 1 to 1,000 weight in volume neosporin bladder irrigation. How many grams of neosporin are required? So you have its weight in volume, so it's 1 gram over 1,000 milliliters for the volume. And again, you have 2 liters, so you're going to have 2 liters down here with the volumes together. And then, of course, you have your X grams. If we got to check our units, they're the same on top but different on the bottom. So we would, easier to change the 2 liters to milliliters. So 2, how you would do that is because you're going from liters to milliliters, you would multiply the number by 1,000. So 2 times 1,000 would be 2,000 milliliters. Okay, then you cross multiply. Whatever you multiply the X by always goes on the bottom, which would be 1,000. 1 times 2,000 would be 2,000. Goes on top. Again, you can mark out your zeros because you have 3 on top and 3 on the bottom. 2 divided by 1 would be 2, so the answer will be 2 grams. Next, we have a 1,000 milliliters of a 1 to 10 weight in volume sodium hypochlorite solution is ordered. X milligrams of solution of the hypochlorite do you need to weigh? Okay, so we know we have the 1 to 10, and it is weight to volume, to be grams to milliliters. You know you want X grams, and you have 1,000 milliliters. Okay, so our units are the same on top and the bottom. So you cross multiply. X always goes on the bottom, so 10 times X will be 10. 1 times 1,000 goes on top. Okay, you have 1 0 here, 1 0 here. 100 divided by 1 is 100. So your answer would be 100 grams. Next we have how many milliliters of a drug solution are needed to prepare 2.5 liters of a 1 to volume solution. So it would be milliliters to milliliters. So we know we have our 1 to 20. And of course these are going to be your milliliters. You're going to have X milliliters up here to prepare 2.5 liters. Okay, so now we have milliliters down here, liters down here. We need to make this milliliters. So if you're going from liters to milliliters, you multiply it by 1,000. So 2.5 times 1,000 be 2,500 milliliters. So then you just cross multiply. Whatever you multiply the X by goes on the bottom. I'll do it down here. X times 20 be 20. 2,500 times 1 is 2,500. Again, we can mark out 1 0 on each one. 250 divided by 2, or you can say 2,500 divided by 20. It'd be 125 milliliters. Number 4, you need to prepare a 750 milliliters of a 1 to 500 weight in volume potassium. How many grams are needed? Okay, so you have 1 gram over 500 milliliters, and you're asking for X grams, so that's going to go on top, divided or over top 750 milliliters. Our units are the same on top, the units are the same on the bottom. So then we cross multiply. Whatever multiply the X by goes on the bottom. 750 times 1 be 750. Again, we can mark out 1 0 because we have those in common on each one. And 75 divided by 50, or 750 divided by 500, is going to be 1.5 grams is their answer. Next, we have a drug is available as a 1 to 1,000 concentration in a 20 milliliter vial. Which is too much information there. You don't need to know the vial. The patient order is for 12.5 milligrams. How many milliliters are required? So we know we have 1 gram over 1,000 milliliters. And then you have 12.5 milligrams. We'll put our weights together and have X milliliters. Okay, so our units on the bottom are the same. Units on the top are different, but they're both weights. So we want to make this gram milligrams. Or you could have made the 12.5 milligrams grams. So let's do that just to do a little bit different here. Because the 1 gram to milligrams would have been easier because you could do 1,000, but just to show you the other way. So with this one, we're going to go from milligrams, of course, to grams. So I want to do this because this is the opposite. Because you're going down, you're going to divide by 1,000. So you take 12.5, you divide it by 1,000 to get grams. And once you divide it, it's 0.0125. But it really doesn't matter which size you convert as long as they're both the same. Okay. So whatever you multiply the X by always goes on the bottom. So 1 times X is 1. 0.0125 times 1,000, okay, would be 12.5. 12.5 divided by 1, of course, it's 12.5 milliliters. Number 6, what is the percent strength of a 1 to 60 solution? So again, we did this one in the last chapter, but when we just changed this part of it, okay? So we know we have 1 gram over 60 milliliters. And the percent, remember, if it's a percent, or if I'm trying to find X, it always goes over 100 milliliters. So, and this will always be grams too. So the units are the same on top and the bottom. X times 60 would be 60. It goes on the bottom. 100 times 1 would be 100. Again, you could take this out if you wanted to, make the calculation a little easier, or 100 divided by 60, or 10 divided by 6. Should come out the same. So it's 1.66. And then the 6's keep going out. So then we're going to round that to 1.67%. So this will be the last one I do because I think these are pretty easy. How many milligrams? So we have the X milligrams of boric acid are needed to make 150 milliliters of a 1 to 400 weight and volume solution of boric acid. So it'd be 1 over 400. Again, it'd always be gram milliliters for a weight and volume. Then you want to do X milligrams over 500 milliliters. So you multiply, whatever you multiply the X by always goes on the bottom. So 400 times X would be 400. but I'm going to stop right now because I just noticed I didn't check my units. So milliliters and milliliters are same on the bottom. The units on the top are weights, but they're both different, so we need to change that. So 1 gram times 1,000 will be 1,000 milligrams. So 1,000 times 500. Oh, that's not supposed to be 500. I don't know what I did there. That's supposed to be 150. I'm sorry. So 1,000 times 150, of course, would be 150,000. I think my brain's getting tired, so I apologize. So 150,000 divided by 400, or you can take out 2 zeros here, take out 2 zeros here. It's easier on the calculator. I think people make less mistakes if you have less numbers to punch in. So it'd be 1,500 divided by 4. It'd be 375 milligrams. So I apologize. I wrote down 500. I don't know why I had that stuck in my mind. But if you have any questions with this chapter, please feel free to email me or stop by my office, make an appointment so we can go over it.